Okay, here we go. Day 2, we'll be working with the design process. Okay, so here's the basic order of the design. We need to define the need, brainstorm, create our design, build our rope runner, and then we test our rope runner to see does it work, what do we need to fix, and then we redesign it based on what we find out when we test it. We rebuild it, we share solutions. It's a whole circle. Now, while these are the order of the steps that I'm giving you, engineers often bounce between steps if they need to, so which is what we'll be doing today. So feel free to go back within these steps, or if you want to change something in your main goal, design, or build. Now, define the need. What is our main goal when creating a rope runner? So we're trying to build a rope runner that travels from the top of the rope to the bottom of the rope as fast as possible. So this does not mean that you need to make your rope runner faster than the starting base rope runner that you get. In order to achieve this goal, we'll be making the structure of a rope runner design as fast as possible. So creating a design that uses what we learned to be sleeker and faster. That way we can still create a design that is the object or the creature that we want it to be. Now, let's brainstorm some ideas. What are some things you need to make a fast rope runner? You can go ahead and unmute yourselves and just speak out.
You need to have a tiny structure so it goes faster. Good balance.
Okay. Start here, a smaller structure. I heard good balance.
Wait. You need balance.
Balance, yes, balance is very important.
Someone said wait.
Wait, okay. Let's see, wait can sometimes matter. Oh, that was quite the feedback. Okay. So weights matter based off of air resistance. So if you have a lot of air resistance, then you're going to need more weight.
It needs to be light.
Oh, feedback. Okay. Okay, so it needs to be light. Let's see. So the weight of the rope runner often depends on how much air resistance it has. So if you have less air resistance, then the weight won't matter as much. But if you have a lot of air resistance, then you're going to want it to be a little heavier. So smaller structures, balance, we need to consider the weight of our rope runner. Okay. Let's see. What about forces? What about friction? What do we need to do with friction?
Force?
Yeah, less friction. There we go. So a smaller structure, I see smaller structure and less friction. These are very similar because we're both decreasing air resistance. So if you remember that term from yesterday. Okay. Oh, looks like we have some chat. Weight, force. Okay, so increase the force of the rope runner going down the rope. There we go, very nice. Okay, there we go. Okay, so now we're going to move on to the next slide. Very good, guys. Those are some great suggestions. Okay, so now we'll be working with balance and we'll learn all about that. Now, how does balance work? So if you remember talking about gravity, I talked gravity about some of you guys. So, and it's an invisible force that is always present. Well, Then we have the balancing point, the center of gravity of a rope runner. And so this is where gravity is pulling on the rope runner. And it is also why when the balancing point crosses the center of the rope, or when the rope runner is unbalanced, it falls over, it tips to the side. So most balancing points are halfway across an object, and it's where the mass or the weight are equal on both sides of that balancing point. So if I take this pencil right here, or this pen, so where do you think the balancing point of it on it is?
On the where you write.
Where you write? So if I put my finger right here, will it balance on my finger?
Yes.
Do you want me to try? Ready? I'm gonna let go with my right hand. There we go, not quite. Remember, the balancing point is where the weight is equal on both sides. So maybe if I did it this way.
If you put it sideways and put the middle on top of your finger.
Yeah, like this?
Yeah.
Yeah. Oh, I think so. It's still kind of tilting, but we got this piece right here. That's going to make it heavier on that side. So it'll balance right there, because that's where the weight is equal on both sides of that balancing point. See that? Do you guys want to try that? You want to take your pencil and find the balancing point of it? Where does it balance on your finger?
The middle.
Yeah. Woo, kind of tricky, huh? Kind of wants to wobble on there. Okay. Now, we're going to try this with ourselves. This time, instead of using a pencil, we'll use our bodies. So if everybody can stand up, we're all going to stand on one leg. Ready? There we go. Just like lift up one leg. Now tell me, is it easier to balance with the arms by your sides like this, or with your arms stretched out like this? Like this by your side, or stretched out like this? You can go back to your computer and unmute yourself if you look. With your arms out? I think so, yeah. Yeah. So now if we pick up something heavy, like a full water bottle or a large cup, let's see, what do I have around me? Let's see, I'm holding, let's see, I have a trash can next to me, so I'll hold that. So if I'm holding a trash can in one hand and I raise up one leg, I kind of lean towards the hand that has the heavier object in it, like that. Now, why is it that we're not falling over when we have a heavier weight? Oh, I'm still falling over anyway. So why is it that we're not falling over when we have a heavier weight?
Because we're pushing all the force to the thing that we're holding.
Yeah, we're using force to hold this up. We're also kind of adjusting our balance. So here I kind of tilt out my hip the opposite direction. And this way, I kind of even out my weight so that it's still equal. Do you see that? What do you guys think? Okay, I'm getting a little tired. What did you guys do to keep your balance? Yeah, go ahead and unmute yourself. Audrey, you can unmute yourself.
What will we need this today?
Yes, we will. So we will be using that at the very end.
Okay.
Okay. Cool. There you go. So that way, if you notice for this activity, when you held a heavier object, you had to shift your weight to create an equal balancing point. So you had the same weight on both sides. Okay. Now, we're going to think about our design. So this is where we're going to take out this piece of paper, the one that has the rope runner, the front, and the back side. Oh, that's upside down. Does everybody have this piece of paper? Yeah, I see a couple of you grabbing it. Okay, very good. I see all of you have it. So now we're going to consider what we want our rope runners to look like, what materials we need to make it, and we're going to make sure it's balanced and use everything that we've learned. So before we start building our rope runners, we have to make a picture of what it's going to look like and what we need to use to make it. So our design, you can choose whatever you want. You can make it into an animal or a creature, a person, but you also have to choose what will affect the speed of your rope runner. So currently, everybody's given the same rope runner. So all your rope runners are the same speed. But we're all going to be choosing different designs. So you have to make your design be as fast as possible. So what did we learn that affects the speed of your rope runner? Can anybody tell me what did we learn that affects the speed of our rope runner? How do we make our rope runner faster?
We need something heavy at the two ends and something light in the middle and something light on the bottom.
Okay, so you have to have balance. Is that what I'm hearing?
You have to have good air resistance.
Yes, air resistance, that's very important. Okay, those are very good suggestions, very important. Balance and air resistance. So as we create your design, you should keep things in mind. So if you wanted, for example, if you wanted to create a butterfly, we have these big wings spread out to the side. What do you think will happen?
It will slow it down.
Yes, it will slow it down because it decreases or it increases the air resistance. Now, what are some ways we can redesign this big butterfly to make it more air resistant?
You would make it smaller so it had smaller wings, like it was a baby butterfly.
Okay, yeah, baby butterfly. Any other ways? Let's see. Any advice? Is there some way that we could keep the giant wing size and still decrease air resistance? Oh, let's see in chat. Let's see, Bella. We said hard wings. Oh, hard material of wings, like wood. So a heavier material or a harder material, maybe. We'll be testing out some of these. Let's see. Okay, any other suggestions? Any other ways to keep these large wings and decrease air resistance? What if? Oh, go ahead.
Maybe you could make the wings a little bit larger than small, maybe a little medium.
Okay, decrease in size.
You could make them slanted, so they were like how the race car has the thing at the top, but they're just slanted like the butterfly wings. So the butterfly wings are slanted like a race car.
Oh, so kind of like back like this. Yeah, there we go. That's one way. There's definitely less area now for the wind to go against. Okay, very good. Okay, so now we're going to test out some of these ideas with this handy dandy rope runner I have right next to me. So on this one, I added Velcro and I added a wire frame so we can test out different materials and different weights to see how they affect the rope runner. Okay, What do you think will happen if you add more weight to one of the sides? I think we've covered this. You want to shout it out?
It won't be balanced, so it's just gonna fall off.
Yep, exactly.
It's
So
going.
like if I hold it here on my finger and we take one of these weights and just add it to that side, you can see how the rope runner tilts like that. Okay. So what if I just added more weight to the rope runner in general? Do you think that'll make it faster or slower?
I think that would make it slower.
Make it slower? Okay. I have a larger weight. So first, we'll see the speed of the rope runner without any extra weight on it. Like this. Okay, here it is without any weight. There we go. And now, I'll use more weight. I'm gonna add weight to our rope runner. Just like that. And we'll roll it again. Here we go. Let's see. Did you guys notice any speed difference?
It made it go slower than it was before.
No. That may be, I find it kind of difficult to tell. I think maybe if we timed it, it might be more accurate, but I think it kind of went the same speed. Did anybody else see that?
Yeah, it was kind of hard to tell.
Yeah. Okay, let's see. What if I add something to the frame? So let's look at air resistance. I have 3 different objects. I have a piece of cardboard. I have some fabric. And then I have some tulle. Now, what do you think? How will the cardboard affect the speed?
Less holes, so there's more like the air. What was the word? Air resistance.
Well, air resistance, right? So let's roll that down. We need a rope too. Here we go. Oh, let me move my chair out of the way. Make sure that wheel is on the rope. That can be tricky sometimes. And let go. Yes, that definitely went slower that time. You can try that with a larger piece of cardboard too. Yeah. Okay. How about if I add the fabric on? Will the fabric decrease it like as much as the cardboard did?
It would decrease the air resistance a little bit because it's more floppy, but it still would have the air resistance.
Okay. So you're going to say it's less than the cardboard, right?
Yes.
Okay. Let me clip this on. I'm just going to clip the fabric onto the wire frame. Use some paper clips. Very handy. Okay. There we go. So now I have the fabric attached to the frame. Oh dear. One moment. It looks like I lost a piece of my rope runner. In your kit, you'll notice your axle comes with 2 things on either side to keep it in place, and I lost one of them. Okay. Here we go. Found a spare for the time being. Let's roll this down. Okay, rope runner with fabric.
Are we supposed to start building the rope runner?
Not yet. For now, we're looking at how different materials affect the speed of your rope runner.
Okay.
It was more faster than the cardboard because it was lighter than the cardboard. If you go like this and you have the cardboard in one hand and the fabric in the other, the cardboard is heavier, so it made the rope runner slower than it's supposed to be. So you'll need the fabric instead.
That is very close. The fabric did make it a little bit less air resistant, but the fabric is actually heavier than the cardboard. It's just the fabric moves and it's not as hard. See how I can't bend that? But I can bend the fabric, it's all wobbly. So the fabric has less air resistance because it can be pushed back. And so in that way, there's less surface area. Okay. Oh, but now we have our last material is this tool. You can see that? It's kind of see-through, a little stretchy. What do you think? Compared to the cardboard and the tool, compared to the cardboard and the fabric, what do you think will happen to the speed of the rope runner?
It would probably go really fast because it is really light. And it would probably, because it's not that big and you can wobble it, and you can, like, it would make it go so slow. It would give it air resistance.
Yes, it would give it air resistance. So the weight won't matter as much as the fact that this is not as solid as an object as a piece of cardboard, and it's not as solid as the fabric, so it allows air to pass through it. So it should make the rope runner faster. Let's see. Well, drop the axle somewhere. Okay. One moment, I lost that piece of axle again. It keeps falling off. Okay. And another spinner. Okay, so here's the rope runner with the tool. Here we go. Oh, it's here.
That went way slower.
Yes, it was way slower because this, with its Velcro self, got stuck to the balancer of my rope runner and made it off balance. And so the off balance of my rope runner slowed it down. So now that I'm going to take the battery off, and we'll try this again. Here we go, rope runner with tool. There we go. There we go. That's better. Yep, so the tool isn't as, you can see through it, it allows air to pass through it, and so it is a faster material. Let's see. What if we added weight to something like the cardboard? Would that help it make it faster or make it slower?
It would make it slow.
Okay. Does anybody have other guesses? Feel free to speak up. Let's see. Make sure this is balanced.
It will go slow because you have two objects on it. So it'll go slower because it won't be balanced because it will go down, but it will be it will be like fast or slow. It will be medium. So it's like in between. It's because the cardboard is heavy and the tool is light, so it'll make it go fast or slow.
Okay. So it's
I agree with her.
okay, so you say it'll make it slower. Let's find out. So I'm gonna roll down the rope runner with just the cardboard, and we'll look at that speed. Here we go. Okay, kind of slow. Okay, now I'm gonna add the weight to the back of my rope runner. Like that. Um, oh, it's falling. Oh. Okay. Ah, it's broken. It's okay. Okay, so what do you think? Did adding the weight make the rope runner move faster or slower?
They made it go faster because it's heavy, so it's balanced now, so it'll go faster.
Yeah, it did make it go faster, but it was the rope runner was already balanced, so it's not all about balance. It made it faster because adding weight when you have a lot of air resistance helps get rid of some of that air, the effect of the air resistance. So if you have a lot of air resistance and you add weight, it gets rid of some of the effect of the air resistance. Okay, so now we look at some of the materials and how the weight affects that. Now we can design a rope runner. This is where we're going to take that piece of paper that you got in your kit, and you can draw what you want your rope runner to look like. So we have a front side, and then the back side. So you can do like a side profile, and then like a front profile. And then you can also write down what materials you want your rope runner to have on it. And then why you think those materials make it like more air resistance or better balance, or how your design makes it balanced. Okay. So we got that. So we're gonna spend 20 minutes on the design for our rope runner. Does anybody have any questions?
Yes, could you repeat the instructions? You glitched out for me.
Oh, no problem. Okay, so we have the piece of paper that you're given, and you're gonna draw a picture of what you want the front of your rope runner to look like, and then what you want the side of your rope runner to look like. And then over here on this side, you're gonna want to write what materials you want your rope runner to be made out of, and then why you want to use those materials, and how your design is air resistance or balanced. So how your design is balanced, and why the materials help increase the speed of your rope runner.
Okay, thank you.
You're welcome.
Do we also write down the name of it?
Oh, yes, thank you for reminding me. Okay, so up here, you can write the name of your rope runner, and then there should be a sticker as well. And that sticker you're going to place on your rope runner when you drop it off at my house. So you're also going to write the name on that sticker and then stick it on the balancing point of your rope runner like that. Does everybody see that? I stuck my sticker on my rope runner. And so that'll also have the name of your rope runner. So, I made that rope runner last year. His name is Harry Potter. So remember, as you're drawing out the design for your rope runner, make sure that it is balanced and that the materials that you choose are less air resistant. So we will come back together at 1:55 and then we'll share our design.
While we're on that break, are we supposed to build this?
Oh, I think you broke out. What did you say?
Are we supposed to build this on our break?
We are not building it. We are just drawing the design for your rope runner.
And what time did you say?
So you're just drawing a picture of what you want your rope runner to look like.
Mm-hmm.
And then you're filling out the materials list. And you're answering the question of how these materials make your rope runner fast. Does that answer your question?
What time do we get back onto Girl Scouts? I forgot.
Oh, so you're not logging off. You're just gonna spend the next 17 minutes working on drawing your rope runner and deciding on the materials. So we're not building anything yet. We're just gonna draw draw and plan.
Are we supposed to write what we want our rope runner to look like on the picture?
Yes. So I gave, yeah, it's just like an outline and you can draw your picture over it. And that way you don't have to spend time drawing the actual build rope runner. You can just draw your design on it.
Okay.
Okay, I'm gonna pause recording and then I'll unpause it when you get back together and discuss our ideas. For a second. Okay, so here are some examples of rope runner from the rope runner page. This is where I ordered the rope runners off of. So they have lots of examples. We have animals, a lion, I think it's a frog, a lobster.
So did you buy like the top of your rope runner from here? Did you buy the top of your rope runner from here? Or
These are where I bought all of the rope runner kits. So all the wooden pieces that come in those bags, that's where I got them from.
oh, okay.
Yeah. So on their website, they have all these examples of different rope runners. So we've got insects, women in history, and then other creatures. We have a mermaid. We have Santa Claus. We have a comet. And then we have different careers. My rope runner personally is Harry Potter, so he's a fictional character. And then my mom made a rope runner as well, and she made a fairy. You can make them into whatever you want. Okay, so we are not putting anything on our rope runners at the moment. We're just drawing out the design.
Are we supposed to do the side too? The other
The
one?
second page?
Yeah.
Yeah,
Okay.
the second page is just the side view of who you're drawing. Like, this is the front of Harry Potter, and this is the side of Harry Potter. And then these are the materials that I'm using to make him. And this is why I think those materials are good to use. Like, they are less air resistant. Why are they less air resistant? That type of thing.
Okay. Thank you.
You're welcome. Okay, we're back, and everybody's created at least or started their design. So we're going to collaborate on that. Cool. Go back page. Okay, so does anybody want to share what materials they're going to use to make the rope runner?
Paper and feathers for my butterfly.
Okay, and so how are these materials going to make the rope runner faster? What's your idea?
I think the paper and feathers will make it light because they're both not that heavy.
Okay,
And I think it'll make it faster.
okay. I see the feathers. So the feathers allow a lot of air to pass through them, right?
Yep.
Okay. Now careful with that paper. You don't want it to be like the cardboard where it blocks the wind. So, but they're very good. Does anybody else have any ideas?
I might use counterweights just to add some weight to mine.
Okay. So, yep, that way it'll counter the effect of the air resistance, right?
Yes.
Okay. Anybody else? Any other ideas or what materials? You don't have to share your idea. You can just share what materials you want to use. Okay, well, it looks like we're off to a good start. now that we've brainstormed different ideas on how to make a fast rope runner, we talked about how materials would decrease air resistance. So, less surface area and just alternate designs so that it doesn't completely stop motion. How the weight affects the balance and affects the speed. Does anybody maybe have any ideas on how to improve your design of rope runner based on what we talked about? Now that you've heard other people's ideas, does anybody want to change anything on the rope runner? So earlier we had that somebody wanted, instead of making butterfly, to make a mermaid. Audrey, I see you shaking your hand. What do you think?
Oh, I'm just saying, I might have to redesign because I don't know if a jelly bean is even gonna work.
Why not?
Because actually, I didn't even think about why it wouldn't.
If you want to make a jelly bean, make a jelly bean, and it'll turn out awesome. So you can always use like instruction paper. You can cut out the shape of it. That would be maybe something you could do. Let's see. Anybody else have any thoughts? Maybe something that you think, hey, now that I've heard all this stuff, what can I improve on my design?
Can I tell you my idea for the my rope runner?
Yeah, go ahead.
I want to make a cow fly. It's a butterfly and a cow mixed together.
That is a really good idea. I love how creative that is. You're like, it's some sort of mythical creature. Did you make it up or did you hear about it somewhere?
I made it up.
Awesome. That's going to be really cool. I can't wait to see it. Okay, that was some good discussion. So now that we have our designs, you can continue working on your design and improving on it, or we can go and make our rope runners. Or most of it, or you can do both. So now we're going to take time and start building our rope runners. So, the rope runner is provided for you. Some rope is provided, so you can set up a practice track. So remember the steps of the design process. You can always, after creating your rope runner, test it out, evaluate how it works. Did it lose its balance? Is it too slow? And then decide how you want to change your design in order to improve on those things. So if it falls off the track, how can you make it balance? Add more weight to the other side to keep your rope runner balanced. There we go. So we're just going to take the next hour and just kind of hang out on Zoom. I'll keep this open in case you want to ask any questions or share your ideas. Otherwise, our presentation is done. So everyone will have the next week to make their rope runner. And on Thursday and Friday, I will have my front porch set up for rope runner drop-offs. And I'll send out an email to your troop leaders this evening about how rope runner drop-offs are going to work. Does anyone have any questions?
Are we going to build these by ourselves?
You don't have to build them by yourself. Feel free to ask help from your parents if you need it.
Okay.
Okay, so now that you've created a design by yourself, just work with your parents, make sure you keep your design, keep your ideas, and improvement is always an option. That's always good. But yeah, if you need help, go ahead and ask your parents. Any other questions?
Is
Okay.
it going to be hard to make?
Oh, I'm sorry, what's that?
Is it going to be hard to make?
Well, it will not. It's like, basically now that you've done all the stems and all of the brainstorming and research, you have your design, so now you're just crafting it. So glue, tape, and your materials. So now it's like seen instead of just done, because you have this art aspect to it. Okay, so I guess the difficulty depends on how intense your design is or how difficult your design is.
What's your number for Girl Scouts,
And if you
Sophia?
are finding that your design is too difficult, you can always simplify it.
Can we leave and start building hours?
Yeah, so now that I'm done with the presentation, feel free to leave. This is my email and my phone number, so if you guys have a question, you can just text me or send me an email.
43156.
Yeah, but yeah, you can feel free to leave to start working on your open, or you can just hang out in the same room. Just keep
Bye.
the meeting open. Okay, bye. Nice
Bye.
seeing you guys. See you at race day.
Wait, we're not supposed to leave?
I don't know.